So we're now going to look at 2.8. So we just did 2.6 and 2.7. So we're going to finish up today with 2.8. We're going to look at function notation and how function notation works and how we can work with functions. Now, all the operations that we can do with numbers, we can apply to functions. We can add them, subtract them, multiply, and divide functions. And just so we make sure we understand the nomenclature, we're going to write it up two different ways. So you see how it's written and how we actually apply it. So if we want to find f plus g of x, well, that is the same thing as f of x plus g of x. So that's the equivalent. This is kind of like the shorthand way of writing it, and this is what it actually means. How about f minus g of x? Well, that would be f of x minus g of x. That's the way we would apply it. Multiplication is done the same way. F times g of x is f of x times g of x. And the last one is division, and that's f over g of x. And that is f of x over g of x. And then they add in this caveat that g of x can't be 0, okay, because you don't want division by 0. So when we look at division, we also have to worry about the domain and see if it's possible or not. So these are our operations. So we can add, subtract, multiply, and divide. Later on this evening, we're going to look at composition, which is an extra operation that applies only to functions. These are very, very simple to do. We're going to look at a couple of examples of each one. We'll do one with numbers and one with the variable. So I have to give you two functions, and then we're going to work with these two functions. So let's say we're given these two functions. Let's say you're given f of x equals 5x minus 2, and g of x equals 8x plus 1. And let's try to do addition first. So let's try to find f plus g of 3. What would that be if I write it out? Well, that would be f of 3 plus g of 3. So we write it out. Now, here's what we have to remember about these. If there's a number inside the parentheses, our answer is a number. If there's a variable inside the parentheses, our answer has a variable in it. So when we do this one, that 3 is inside the parentheses. So we're going to get numbered answers for both of them. And what we do is we simply plug the value in to each one of them and then add the results together. So first we're going to find f of 3. And f of 3 would simply be 5 times 3 minus 2, which is 15 minus 2, which is then 13. So that comes down here as your 13. Then we repeat the process with your g of 3. And g of 3 would be 8 times 3 plus 1. And 8 times 3 is a 24, plus 1 makes it 25. And then we simply add them together. And 13 plus 25, well, that's going to be a 38. And that is f plus g of 3. Right, so there's your answer there. What we did was we plugged that number 3 in, and that gave us that 38 out. Number goes in, number comes out. Let's use the same functions. And now let's add them together with the variable. So we're going to use the same functions. And let's try to find f plus g of x. And it's actually easier with that variable than it is with a number. So we don't have to calculate anything. So we want to find f plus g of x. Well, breaking that down, what is that? That is f of x plus g of x. Our answer has to have a variable because there's a variable inside the parentheses. And this is just simply copying them down and combining them together. So what is f of x? F of x previously was defined to be what? 5x minus 2. So that's going to come down as simply a 5x minus 2. What about the g of x? What is it? It's simply 8x plus 1, right? And now we can combine these together like we would any other function or any other expression. 5x and 8x makes it 13x. Minus 2 plus 1 makes it a minus 1. So that is f plus g of x. That's all you need to do on that. Now let's look at subtraction. It works the same way. I'm not going to do one with numbers because we can plug the numbers in. I'm going to specifically focus on one with variables because we have to distribute. So I'm going to give you two new functions. And let's say you're given f of x to be 8x minus 4 and g of x to be x plus 9. And I want you to now find f minus g of x. So rewriting, that is simply f of x minus g of x. And this is very simple, but here's where students make a mistake. With that negative, we have to use parentheses, and we have to distribute that negative through. So all we do first is we copy down f of x. And what was f of x? 8x minus 4. Then you bring down your negative, and you're going to have to use parentheses now, because it has to be distributed through. And what is my g of x? G of x in this case was defined to be x plus 9. And that negative has to go through. So now I'm left with 8x minus 4 minus x minus 9. And when I combine all of this together, I'm now left with f minus g of x equaling now what? Let's combine our like terms. We've got an 8x and a minus x, so that makes it a 7x. And we've got a minus 4 and a minus 9, that makes it a minus 13. And that's all you need to do for that. And multiplication is going to be done the same way. We'll do two quick examples for multiplication. So I'll give you a new function to work with here, and then we'll use multiplication. Okay, so let's say you're given this. Let's say you're given f of x to be, how about x squared minus 4, and g of x to be 3x plus 5. And we'll do one with numbers. So remember how that works, and then we'll do one with variables. When we do the variables, we're going to have to FOIL. So when we do the variables, we FOIL. Okay, so let's say we're wanting to find f times g of -3. If I write that out, what is that? That is f of -3 times g. Let me write it out so it looks right here. Times g of -3. So it's f of -3 times g of -3. And what do? We do each one individually. We do them separately. We've got a number inside our parentheses, so our answer has to be a number as well. So we plug that -3 into each one, put them back together, and multiply the result. So f of -3 would be -3 squared minus 4. So that's 9 minus 4, which is then a 5. So that piece comes down as a 5. So these are not difficult once you understand the concepts. We need to then find g of -3. That's going to have a number as well. G of -3 would be 3 times a -3 plus 5. And that's a -9 plus 5, which is then a -4. So bring down our -4, work it over to the side, put them back together. And what's our result going to be? Our operation is multiplication. So multiply these together, and our final result's a -20. And that is f times g of -3. Not much to do on that one. When we multiply, we have to FOIL. So we'll do one in multiplication. When we do division, we have to worry about the domain. So let's do one more. Let's use the same functions again. And let's find f times g of x in this case. Which that is then rewriting f of x times g of x. This one's a little bit more complicated because we're going to have to FOIL. Remember, those are our original functions here. So these are the ones we're going to be using. And we're going to have to FOIL it and then combine like terms. So let's go ahead and write this out. F of x was x squared minus 4. G of x is 3x plus 5. And now we've got a FOIL. So we've got them written down. We're going to have to FOIL. We've FOILed many, many times, so nothing new at all here. We're going to go ahead and FOIL. And when we FOIL, we take the first times the first, outside times the outside, insides, and last. So let's go ahead and FOIL. X squared times 3x, that makes it 3x cubed. Okay. X squared times 5, that makes it a 5x squared. Inside, we've got a minus 12x. And last times last is a -20. Nothing goes together. So that is our final answer of f times g of x. We can't combine anything together because it's all different. So that would be simply our answer there. So all you need to do for multiplication, you've got that variable x, is write them out in FOIL. Not much to these at all. With division, we have to be careful about the domain. If it's just a number, it's not a big deal. But if it's got variables, we need to make sure that we don't get division by 0. So we want to find the domain as well and what numbers won't work. So I'll give you two of these. We're going to be given two of these new functions. So how about f of x is 4x minus 3, and g of x is x plus 9. And let's go ahead and find f over g of x and the domain. So we want to find our division, and we also want to find our domain. So we want f over g of x, so that is f of x over g of x. And these are very simple. We just have to be careful about the domain. So f over g of x would simply be 4x minus 3 over x plus 9. Now, remember back from 1-5 when we talked about rational functions, we need to make sure that we don't get division by 0. So how do we find that domain? Well, to get the domain, we set the denominator to 0 and solve. So that is x plus 9 equals 0. So that gives you x equals negative 9, and that is the number that is not in the domain. Because you can't have negative 9, because negative 9 would give you division by what? 0. And if it plugged it in, I would get 0 down below, and I can't have that. So how do I write my domain? Well, I write my domain as negative infinity to negative 9 union negative 9 to infinity. So we've got our function, and we've got our domain. We'll look at one more of these division ones, and then we'll talk about function composition. So next we're going to be looking at composition. We'll do one more of these. This one's a little bit different. So we have to use division. We're going to have to use multiplication as well. So let's say we are given two new functions. Let's say you're given f of x is 4 over x plus 9, and g of x is about x plus 7. And I want you to find f over g of x and also the domain. So that's f of x over g of x. And we have to be very careful when we get this domain. We're going to have to work with it, and we're going to actually get two numbers that don't work. When we plug it together, we'll see what numbers won't work. But there's actually going to be two of them. So when I rewrite that, I get then 4 over x plus 9 over x plus 7. How do we handle this? Well, this is a complete fraction over another fraction. So when we have a fraction over a fraction, what do? Invert and multiply. So the top fraction stays the same. The bottom fraction gets flipped over. So I'm going to go ahead and take that bottom fraction down here, and I'm going to flip it over. So top fraction stays the same, bottom fraction gets flipped over, and that's going to be then 1 over x plus 7. And when we put them together, what do we get? We get 4 over x plus 9, x plus 7. We had to invert and multiply there. And that is f over g of x. Now, what can we not have? There's two numbers that won't work. What two numbers are not going to work? Well, the two numbers that do not work, that give us division by 0, are going to be what? Just by looking at them, x equals -9 and x equals -7, right? Because those give you division by what? 0. You can't have division by 0 at all. Plug the -9 in there, you get 0. You plug the -7 in there, you get 0. So how do we write our domain? Well, our domain would be -infinity to -7 union -7. Or sorry, I should use the 9 first because that's our smallest value. So 9 goes first. So -infinity to -9 union -9 to -7 union -7 to infinity. So that is basically saying what? That is saying that all numbers are viable numbers to use except for -9 and -7. We had to split it up like this because in interval notation, that's what it would be. This basically says every number works that we can use except for -9 and -7. Okay. Let's now look at function composition. And this is something that might be new to some of you, but it's very easy to do. Function composition is when we splice one function inside of the other. And that is f composed with g of x, and that is f of g of x. And that open circle, that said composed. So that means composed. And what we're doing is we're plugging one function inside of another function. So they're merging them together. Now, when we look at this, we use order of operations. And when we look at these, the g is going to be done first because it's inside. So g is done first. G of x is done first. F of x is second. So you do the g, and then you do the f after that. So I'm now going to give you some functions to compose together. Now, this is not commutative, meaning order matters. It's like subtraction. You have to watch the order because they're different with different orders. So we're going to do 3 of these. So I'll give you a couple of functions here. Let's say you're given f of x is 8x minus 1, and g of x is x squared plus 2. I want you to find f composed with g of minus 2. So that is what I want you to find. And we're going to kind of go through this one a little bit slower. Function composition is something that's new to some of you. And when we do these, one goes inside the other one. Now, think about our answer. I always like to do that first. What do we have? We have a number inside the parentheses, right? So our answer is going to be a number. So number in, number out. Always remember that. Sometimes students get confused and try to use the variables. But if there's a number in the parentheses, you get out a number. When we rewrite this, we get f of g of a -2. Now we do the g function first and we replace. This is just a replacement game. We replace one inside of the other. So first thing we do, order of operations is the parentheses. That's done first. That's why g is first. So g of negative 2. What would g of negative 2 be? Going up to our function, g of negative 2 would be minus 2 squared plus 2. So that's 4 plus 2, which is then a 6. And we take that 6 and we plug it back in. So plug in what it is. And so now we need to find f of 6, and f of 6 is easy enough to get. F of 6 would be 8 times 6 minus 1. And 8 times 6 is that 48. Minus 1 makes it then 47. So f composed with g of negative 2 is 47. Number in, number out. So you just plug one inside of the other. Let's use the same functions again. This time we're going to switch the order. So use the same functions. But now we're going to try to find g composed with f, and we'll switch the number. How about we make it 4? And that means g goes out in front and f of 4 goes on the inside. Now, this one is the opposite of the last one because which one goes first? Well, f is on the inside now, right? Because g was first, so f is on the inside. So f is done first. So the first thing we do, because f is on the inside, is we do f first. So now we need to find f of 4. And f of 4, if we use our same functions again, f of 4 would be 8 times 4 minus 1. So that's 32 minus 1, which is then 31. And what do we do with that 31? We take that 31 and we plug it back in. Now we need to find g of 31. And g of 31, we'll need a calculator for this one, because that's going to be 31 squared plus 2. And we'll definitely need a calculator. So we can square that 31, add 2 to it, and we get 963. And that is g composed with f of, in this case, 4. So what did we do? We did the inside function first, plugged it back in, and then we did the outside. So far, we've only used numbers. It's going to behave the same way with variables. It's actually a little bit easier, but sometimes students get confused as to what goes where. So now I'm going to give you two functions, and we're going to compose them together. So let's say you're given f of x to be 5x plus 9, and g of x to be 2x plus 10. And I want you to find f composed with g of x. So we're going to go ahead and compose these together. And f is out in front because f is first, outside. G of x is in the middle. And we always do the inside first. So this is what we're looking at here. Now, what is g of x defined to be? G of x, if we write it out, is 2x plus 10. So that 2x plus 10, all we do is we plug it in. Just plug it in. We don't have to do anything else. Plug it in. Now we want to find f of 2x plus 10. And this is where students sometimes struggle a bit. Easiest way to do this is we look at our function. We're on the f function, which is here. I want you to write it out with parentheses wherever there's an x. So wherever you see an x in that f function, I want you to use a set of parentheses. So we have 5 parentheses plus 9. And what's going to go inside of our parentheses? 2x plus 10. And then we can simplify this down a bit. So distribute your 5 through. 5 times that 2 makes it a 10x. 5 times 10 is 50. Add them together. Then we get 10x plus 59. And that is f composed with g of x. So you're just plugging one of them inside of the other. It's not commutative, meaning if I switch the order, I'm going to get a different answer. So let's use, again, the same function. And let's now try and find g composed with f of x. And now g is out in front, and f of x is on the inside, right? And you're going to get a different answer. It's not commutative. Commutative means order doesn't matter. So things that are commutative are like addition and multiplication. 5 plus 4 is the same thing as 4 plus 5. 8 times 3 is the same thing as 3 times 8, right? The order doesn't matter. Now, this is not commutative and order matters. Subtraction is not commutative. You can't switch the order in subtraction and get the same result because that minus sign stays there and it gives you a different answer. So this is going to be a different result. We use the same process we did a moment ago. First things first, we find our f function. What is our f function? If we go back up and look, our f function is on the inside, and that's 5x plus 9. So that's going to come down inside the parentheses. And now we're using the g function. So now we go to the g function, and we're going to write out that g function, which is right here, which is that 2x plus 10. We're going to write it out, and we're going to use parentheses for that x. So we have 2 parentheses plus 10. And we fill it in. So that's going to be 5x plus 9 here. And then we distribute that 2 through, just like we did earlier. And see, we get a different result. So that is now 10x plus 18 plus 10, which is then 10x plus 28. And that is g composed with f of x. Simple enough. We're going to look at one more, And then we'll learn how to work composition backwards. And it's actually a little bit easier when we work these backwards. So we'll do one more of these, and this was going to have a power. So we'll do one more. And I'll give you some new functions. So let's say you're given f of x equals now, how about the square root of x plus 3 and g of x is how about x squared minus 3. So let's go ahead and do these, and let's find both of them. Let's go ahead and find both f composed with g of x and g composed with f of x. And they may be the same, they may be different. I think these will actually come out to be the same, but in most cases they're different. So let's go ahead and find each one, because this is like question 2 and 3 in your homework. You have to find the values, and you have to find both of them. And let's see what we get. So we want to find both of these. So let's begin with f composed with g of x. That is f of g of x. And so we plug in our g of x. And what's our g of x? X squared minus 3. Right? So that goes in there in our parentheses. Nothing new. Now we write our f function out. And we're going to use parentheses for that x. And then we got that plus 3 here. Fill it in with an x squared minus 3. And what's going to happen here? Well, the plus 3 and the minus 3, they're going to cancel. So that leaves you with the square root of x squared, which is then x. So f composed with g of x condenses down to x. Now let's see if the opposite is true. Let's see if we get the same x on the other one. So let's try g now composed with f of x, which is g of f of x. And now we plug our f of x in first, which is a square root of x plus 3. Write your g function out with parentheses. Fill it in with the square root of x plus 3. And what do we know about a square and a square root? When we square a square root, what happens to it? They cancel, right? They're opposites. So do you see how I plugged it in? Rewrote it. I just plugged in my f, which was up here, okay? And then I rewrote my g function with the square and the minus 3. Plug my value in. What happens when I square square root? Cancel. So that leaves you now with x plus 3 minus 3. So then my final answer is the same, and that's g composed with f of x. Now we're going to work backwards. So now I'm going to give you a function, and you need to tell me what two functions it could have came from. And there's lots of different answers on these. It's just order of operations. So we're going to let h of x be f of g of x. So this is what we're going to define h of x to be. Now, we remember g of x is on the inside, So g of x is first. And f of x is on the outside, so f of x is done second. Now I need to find out what functions this could have came from. And there's an infinite number of answers that it could be. I'm going to show you just the common ones, how to get them. It all is nothing but an order of operation. So let's say your h of x is the square root of x minus 5. And I want you to find now f and g of x. G of x is done first, and f of x is done second. All this is an order of operations game. What do I do first? If you're given this problem, do you do the square root first, or do you do what's underneath that root first? So what's going to go first? Whatever's underneath, right? Order of operations. Here's just an example. This is just an example with numbers. How would you work this one out? If I gave you the square root of 30 minus 5, all underneath the root. First thing you would do is you do what's underneath the root, which is the 25, right? And then square root of 25 is what? 5. We're going to do the same thing over here. What do we do first? What's underneath the root? What's underneath the root? X minus 5. Okay, so that's first. Order of operations tells us that goes first. Now, what do we still have left to do? We haven't taken that square root yet. And what we do is we bring down an x, because the x is like the storage in your calculator. So you always bring down that x. And what do we still have left to do? We still have to take the square root of x. So there's your g and your f function that could compose together to give you that. And we'll do 3 or 4 more of these, because these are kind of hard to see and hard to understand, but once you get the hang of it, they're very easy. So let's now say that your h of x is, well, let's say 9x minus 5. So g of x goes first. If I was going to work this out, would I multiply first, or would I subtract the 5 first? Which would I do? Well, order of operations, remember, multiplication's up here, right? Addition, subtraction's down here. So the first thing I would do is I would do the 9x. So the 9x comes down. What's left over? Well, we always bring an x down. We've done our multiplication. What do we still need to do? We have not subtracted that 5, so that's the next part, x minus 5. So there's your 2 functions. Let's try another one. How about we look at 5 over x plus 4. Order of operations, and again, there's different ways of looking at this one. What I would do is, if you're working with numbers here, you do the denominator first, right? And then divide. So the denominator goes first. So what's in our denominator? X plus 4. Easy enough there. We bring down the x. Now, where have we been working at? We've been working in the denominator. So it stays below. What's left in the numerator that we haven't touched yet? The 5. There's your two functions. Let's try another one. And we've got enough time, we'll probably do 2 more, just to make sure we have these down. They're kind of confusing at first, but then they get a lot easier. It's just order of operations. Think about what you do first, and then what goes next. Now we can only do 2 operations. Order of operations says we do what first? Parentheses first, right? What's inside of our parentheses? X minus 7. Easy enough. That's your G. Now what about your F? Well, you bring down the X, okay, because that's that result there, so it comes down. What do we still have left to do? We've got the 4 in front. We still have to square it, and we still have to add 8. Because you can only do it in 2 steps. That's it. So we did the parentheses, brought down the X, then we had to square it, multiply it by 4, and add 8. Let's look at one more. And let's say I give you something very, very similar to question 4 in your homework. I'll just change the numbers. And there are many different ways to do this one. The easiest way would be to do the whole fraction at once. So I'm going to do my g of x first, and that g of x is going to be 5 over x squared, because that's your entire fraction. So we're doing that fraction piece first. Then when I do my f of x, I bring down an x, because you always bring that x down. We've done the fraction. What do we still have left to do? Subtract 7, and that's it. Very, very similar to question 4 in your homework. Just different numbers is all. So now, what have we covered today? Well, we should be able to finish now that chapter 2 homework packet. Next week, I'm going to give you because